we're just going to start with one of the easiest ones, but yet some people still don't know what this means. And then how are you supposed to do the really hard ones if you don't know what a really simple one means? All right, it is 9 to the power of 1/2. What is 9 to the power of 1/2? Write it down. You got an answer. Compare it with the kid next to you. If you do not have a kid next to you, I will assign you a kid. There's a few more kids absent than normal today because of course, weather. Even though by now you should be able to make it to school. All right. So please talk to the kid next to you. This is a simple answer. It's either you got it or you don't. And if you don't remember, maybe you should write this down. All right. How many of you already checked with the kid next to you? All right. If you haven't, check now. All right. That means square root of 9. It's just a square root of 9. It'll be the exact same thing if I wrote that. If I wrote that, everybody'd have it, and it would be 3. But you got to know that this means this. They're the same exact thing. All right. If that's true, then the third root of m could be written in a different way. What's the other way to write the third root of m? That is m to the what? 1/3. Do you understand? This is a big deal. You got to be good at these exponents. All right. So the reason that matters is because if I give you this problem, I say m to the 1/3 equals 2. Everybody write that, please. Then you've got to know how to solve that. And if you don't make this into a fraction, it's hard. If you make it into a fraction like that, it's easy. You just put it to the 3rd power. I can teach a small child to do 1/3 times 3 because it's just 1. And 2 to the 3rd because it's just 8. And you'll have a calculator on this next test, which means if there's a problem that's like 2 to the 3rd and you're like, I can't remember if that's 8 or 10 or whatever, you can use a calculator. So don't stress about that part. All right. So next one. I know that this is going to be a little bit of a stretch, but 125 to the 2/3 power. I taught you how to do these yesterday without a calculator. What should you do first? Do you remember? Do you even know what a fraction power means? Taught you yesterday. Okay, so here I'm going to do this one for you, and if you can do it already, promise not to call on you. Who already has the answer? Because if you know how to do it, you already have the answer. Awesome, like 3 people. Then listen close, because they're ahead of you. They remember yesterday. 3rd root of 125. That's the root. The roots go on the bottom, just like in plants. And that's the 3rd root of 125, which has to be 5. Because how are you going to get a 25 at the end without a 5 times 5 involved, right? So it's 5. The 3rd root of 125 is what I just did, a.k.a. 125 to the 1/3. And I can do it in my head, and so could a bunch of other kids, and it's 5. Why is the answer not 5? Because then you got to square it. That thing on the top, that's the normal power. 5 squared, 25. Who had 25 from the very beginning? All right. Only 2 or 3 people knew. But I taught you this yesterday. See, that's what makes today hard, is because yesterday was kind of hard, and a lot of people aren't going to remember it. So I got to remind you about how to do these fraction power things. If I just said 16 to the 1/2, I hope it would be insultingly easy by now, because we just did one like it. But how about 16 to the negative 1/2? Can you do that? And if you get stumped by one, just do one thing. Don't you see the square root in here? Just do that. And then think about what else you have to do. All right, please compare to that student I always pair you with. You guys behind you. You guys are going to wrote this one. You're going to spare me back here. It's really smart. Don't spin your iPad around. Hint, square root starts by giving you 4, but the answer isn't 4. The square root of 16 is the starting place, but then it's not 4. Talk with that kid. What do you think the final answer is? All right. right. Isaac, what'd you get?
I got 1/4.
1/4 is correct. See, the square root gets done, and you get 4, and then you do the 1 over thing. Oh, no, wait. To the power of 1 just makes this power of 1. And that doesn't really change it, because 4 to the 1 is still 4. It's this negative here that makes it flip and becomes 1 over 4 to the 1. And 4 to the 1 is just 4. So it's 1/4. Please be honest. Who had that without help? Oh, good. It was way better than I thought. All right. Then, next kind. This is also review, but it's just that the number gets big. 81 to the 1/4. Without a calculator, could you do it? Remember, I'm not going to ask you for any answer that's like 2.7. It's got to be a nice, simple number. Do you know what it means? It means what times what times what times what will equal 81. Raise your hand if you think you know. Nice, a lot of people think they know. Keep your hand up if you're willing to volunteer that answer. All right, Joshua, what do you say?
3.
3 is correct. Who had figured out it was 3? All right, good. Then, here's the twist. What if I made it negative 81? Would the answer still be 3, or would it be negative 3? Or what do you think the answer is now? Please, talk to that kid about theories. What do you think the answer is now?
I have no clue.
It isn't 3 and it isn't negative 3. There is no solution. Why? Well, if you try it, try times 3 times 3 times 3 times 3. Of course, that's not going to come out to negative 81. That's impossible. But try negative and negative and negative and negative. It's still going to come out to positive 81. So it's not possible. Just like at some point, somebody had to teach you that you could do the square root of 49, but you couldn't do the square root of negative 49. Do you get that? It doesn't exist. Any even root like this can't have negatives on the inside. Okay? So there is no solution to that problem. All right, get used to that. Some of the hardest questions in pre-calc, the level above us here, is that there is no solution. You do this complicated thing and then you realize, wait a minute, there is no solution. And you got to be really good at math, honestly, to figure out the no solution ones. You can't just like, I got stuck on the problem and I write no solution. They won't give you credit for that. You got to show work. And that's an important point. And today I'm going to be talking about showing work. And I just want to take this moment to say, when you go to AP Pre-Calc, which most of you will, when you get to the FRQs, free response questions on the big test at the end, okay, if you just have the right answer, you can be super smart. Do it all in your head. You get the right answer and you'll get 1 out of 9. 1 out of 9 for getting the right answer. So that's why. Why is that? Because maybe the answers could get out really easy. Maybe you could crane, look at the kids in front of you and realize he's got 25 for the answer. I'm going to just copy that down. They're not going to give you much for just the answer. You got to show how you got it. All right, along those lines, would you please solve this and show me how you get the answer? Show me the work. Because if you don't have the right work, you won't get the points. All right. A lot of people were taught this incorrectly. I hate to say it, but it's true. A lot of people were taught, okay, to get rid of the squared, you square root it, and this is not wrong. So far, I'm right. It's square root. Now, I want to remind you, there's 2 ways to do square root. I could also have taken the same exact problem and done to the power of 1/2. That's a square root, just as much as the square root symbol. Remember, those are the same thing. Okay. Now, I think most of you knew that. I think most of you knew to start with square rooting both sides. But this is the part that I think a lot of people are going to get wrong. A lot of people are going to say that there's plus and minus 5 is the answer to this. These are supposed to be equal to each other, and that is not true. The square root of 25 is just 5. It's just 5. So again, some of you were taught this incorrectly, so now you got to learn this correctly. Because see, if I have proof that what I'm telling you is true. You just have to graph this. Just type, don't do it right now because it takes too much time, but if you just type this exact thing into the calculator, it gives you the absolute value graph. See, it's the absolute value of x. If you don't include that in your work, you won't get the points. You've got to show that the square root of the variable came out the absolute value. I'm warning you, that's the number one thing marked wrong on the next test. I'm telling you ahead of time. In fact, it'll probably happen twice more this year on tests. This is one of the favorite things for higher algebra teachers to make sure you've got is if you are getting a square root of a variable, you've got to have absolute values. Because then that means there's two answers. That's the part that gets you two answers. See, when there's an absolute value, you've got to split it into two equations. And the equation you have in the first place is exactly what you see without the bars. And then the other one, I train kids to just write the exact same thing. Because you'll realize, well, it's not going to be two of the exact same thing. And then you put a negative right there, and then you got your answers. That's how you need to show your work. Because if you show it the shortcut way, and you never put an absolute value in there, you're not going to get the credit. They're going to say you did it wrong. Because they're going to say, if you put a plus minus right here, you're saying the square root of 25 is plus and minus 5, and it's not. Try typing it in a calculator, square root of 25, it gives you one answer. Try graphing it, it gives you one dot, one place, not two. All right, so why is that such a big deal? Because you have problems like this today. Please write that one down. And then confer with the kid next to you on just what's the first step. And then, what's the second step? The second step is what usually gets me. Okay. Talk to that kid next to you. First step, second step. First step, square root, which can also be fraction of 1/2, like this. That's also an okay way to do a square root. Both of those are square roots. Cool. And the square root of 144 is 12. And the second step is like this part, absolute value. Who remembered? It was literally 1 minute ago. I told you this. Who remembered the absolute values? All right, like 8 people. All right. So I'm going to keep on doing this until you get it right. You got to do, anytime you do an even root, it's really picky, but it's math. Math doesn't just give you credit for being close. You can have a beautiful essay and one incorrect spelled word, and you'll only lose a tiny bit, okay, on an English grading system, okay? But here, you do this really beautiful math problem, and you make one little mistake in it, it's just wrong, okay? You gotta be careful. This even root thing, watch out for it, because that's a square root, and square roots bring you the absolute value, and then you bring it into two equations. X minus 2 equals 12, exactly what you see without the bars. And I train kids to do the exact same thing, and you'll be smart enough to know that'd be dumb. I'm not going to do the exact same thing twice. So you put a negative right there. And now you solve those two equations, you got your answers. Okay. That is the hardest thing for today. There's more, but that's the hardest thing. And mostly it's just forgetting that you just did an even root on both sides. Like a square root. All right, now I'm going to add 2 to both sides. X equals 14. I'm going to add 2 to both sides. X equals negative 10. There's your two answers. Okay. Now the next hard thing that I need to teach you is that I just warned you that when you get to pre-calc, a lot of times the right answer is that there's no solution. Okay. These are our two solutions, but do you remember earlier in the semester when sometimes one of your answers wouldn't work. It was called an extraneous solution. Do you remember that? You had to take your answers, stick them in, see if they actually worked. If you forgot that, I'll remind you now. I think 14 works, and I think negative 10 works. But especially in certain circumstances, you need to check these answers. Now, I would say, since your tests only have like 12 questions, I think it's just great for you to check. Anytime you're solving, just take a second and check your answer. You only have 12 questions. So I'm going to check these, and I'm going to show you what I mean. 14 is supposed to work. I go back up here into my original problem, which, by the way, I'm going to rewrite. X minus 2 squared was 144. And 14 is supposed to work. 14 minus 2 is 12. 12 squared is 144. Cool. That didn't take me long to check. And what's the other thing I'm supposed to check? Negative 10. Does negative 10 really work? Negative 10 minus 2 is negative 12. Negative 12 squared is 144. Cool, I checked it. Do you get that at our school dances, for example, that you can't bring a giant backpack in without getting checked? Do you get that? Why would the principal want to check your giant backpack you're bringing in to the school dance? Well, there might be alcohol in there might be squirt guns in there might be really nasty stuff in there, okay? So the point is that you have to check when somebody has like a backpack on, you have to check them. That's true also to go to a baseball game. You can't bring a backpack into the baseball game without them checking it, okay? So why am I saying this? Because this is not the kind of problem you really have to watch out for. Both my answers worked. I checked them, they worked. The kind you have to watch out for look like this. Square root of 3x minus 2 and the square root of x minus 4. If you have a square root in the problem in the first place, this is the kind you have to watch out for. Why? Because it always doesn't work? No, because sometimes it doesn't work. Why do we check the kids' backpacks? Usually they don't have anything in it, but sometimes they do. All right, so I'm trying to tell you which ones to prioritize, and the problems that have a square root like this, that's the kind you got to watch out for. So do you know that you would square both sides? You are correct if you thought that. And if you're like, I wouldn't have known that, then I'll just remind you, the original problem that I wrote in green, I'm going to write it again. What if I had written the problem like this? It would mean the exact same thing. To the 1/2 power means square root. So I'm squaring both sides to fix that. See? Either way, you square both sides. And careful, when you just squared both sides, does that the kind that brings in absolute values? No, it is not. It's when you square root both sides. When you do that to a problem, that's when you get absolute values. Squaring both sides does not. So my answer does not need absolute values. It's just 3x minus 2 equals x minus 4. Now, would you just solve that? That's basic algebra. Solve it from there. You'll get it. And then please compare your answer with the kid next. All right, how many of you had -1? Raise your hand if you did. Awesome, you're all wrong. You heard me say the whole speech about how you should check the answers to make sure it worked. Did you actually check the answer to make sure it works? Because it doesn't work. It doesn't work, I'm telling you. You get down to x equals -1, and then you're supposed to check it. And some of you even checked it, and you didn't see that they had snuck something nasty in the backpack. You didn't check the backpack close enough. I'm putting my -1 in here, and let's just look at this side for a second. Do you agree that the original problem was the square root of -5? That doesn't exist. There's no such thing as the square root of -5. Try it on the calculator, square root of -5. It says it doesn't exist. So that answer doesn't work. You gotta check them and make sure to actually work. And I know it's the square root of -5 on both sides. I know that, but neither one of them works. That's breaking a math rule. I warned you to check, and you still didn't check. And it happened last hour too. It happens all the time. If the problem has square roots in it, watch out. Because a lot of times the answers don't actually work. Because there's no such thing as a square root of -5. All right. I know that's really picky, but that's what math is. Math rewards careful people. Can't just have a, oops, I didn't put enough oxygen in your tank. So when you're down on the bottom of the ocean, 100 feet down, you ran out. Sorry, I made a math mistake. Imagine how terrifying that would be. Your oxygen all of a sudden is out and you're 80 feet down. You tried to take a breath. There's nothing there. Now you have to swim up 80 feet. Probably not going to make it. If you do make it, you're going to have to bend something terrible. My point is, math is something that can even cause people to die because the people do math wrong. I'll give you another good example of this. Did you know that when they first launched a really expensive rover to Mars, that it crashed? All because of a math mistake. Somebody had used feet instead of meters, or meters instead of feet, in one calculation. They didn't catch it. And they sent this thing that cost like $1 billion, which is $1,000 million, to get it there, and then it crashes. It's like one math mistake. All right, so watch out. When? When you have square roots on both sides. So here's another one. It's got a, even on just one side. X equals the square root of x. Seems so simple. But yet it's got lots of complications in it. It's even going to have a quadratic in it. I want to remind you, whenever you have a quadratic, which you will in a minute, quadratics have to be solved after you set them equal to 0. Today's like all the little exceptions that people forget about. You can't solve a quadratic until it's set equal to 0. All right, so I hope you know the first step. Somebody just shout out, what do I do first? Don't be afraid. It's not the first step that ever screws anybody up. It's like at the end when they forget to check the answers. So what do you think the first step is? How about this? Do you get them? I'm never going to be able to solve this when there's a square root there. How do I get the square root out of there? Square it. Yep. Just square it. And now this is x squared equals, what's the square root of x squared? Careful. Is this the kind that has the absolute value or not? This is not the kind with the absolute value. Why? Because we didn't square root both sides. We squared both sides. All right. So now, what did I just say you had to do to solve a quadratic? Set it. Okay, talk to the kid next to you. What do I do next? All right, human nature. You forget stuff. You had a test called quadratics. You had 2 tests on quadratics. All right, and the first thing was you had to set them equal to 0. And I totally get you forgot that. X squared minus x equals 0. That's your first step. Who actually remembered that? Sweet, half the class remembered. Yay. All right, now though, you got to know how to solve a quadratic. And pro tip for you, if you can't figure out another way, my favorite saying comes in on the wall here. If you can factor it, you should. And you can factor this. So, again, we're going to run into half the kids don't know how to factor. Are you the kid that doesn't know how to factor? Let's find out. Show the kid next to you what you think it factors to. Hint, it's got a GCF. Greatest square count. I need honesty. How many of you remember how to factor this? Thank you for honesty. All right, I'll show you. But man, you guys got to remember how to factor out a GCF. Don't they both have an X in them? Can't I factor that out like this? That's what factoring looks like. Put a parenthesis, and anything they have in common, you take out to the front, and then this would be X minus 1. All right. So I think you're seeing you've forgotten a lot of little things. And that's normal. It didn't mean that you never learned it. You learned it. You were tested on it. You're just forgetting it, and that's okay. But you gotta take the time now for this next test. It requires you to know so much little algebra. So much little algebra like this. All right, now that it's factored, there's probably some kids that don't even know what the answer is now. But I think most of you do. X equals this and x equals that. What are the two answers? From here, please tell me you know what the two answers are. This is right off your quadratics test. Now that it's factored, you for sure had a question exactly like this. All right, talk to the kid next to you. What are the two answers? All right, 0 and 1 is correct. Because 1 makes this part 0, x equals 1. And what makes that part 0? If x was equal to 0. Okay, cool. All right. You seeing that there's a lot of rust on your skills? It's like you've been sitting around too long. Okay. So, let's do one more. X plus 1 equals the square root of x. Step 1. How do I get that square root off of there? Square it. But be careful. Is that the kind that has absolute values or not? Nope. It's just x. Cool. If you had square rooted both sides, you'd have absolute values. But how do I square this? Do I just square the x and square the 1? What you really do is you square it like that. All right. So now you remember that that means x plus 1 times x plus 1, right? And that means x squared plus 2x plus 1. And now I know some of you have forgotten how to solve a quadratic. Carlos, first step. Minus the x so that it'll be equal to 0. You want it to be equal to 0. X squared plus x plus 1 equals 0. And then, did you even think about factoring it? Raise your hand if you thought about factoring it. Cool, because that's what we just did a second ago, is it factored it, but this one won't factor. All right, we're going to stop because this will get us too far down this crazy road where we'd have to use the quadratic formula, and it has 16 parts, and I don't need you to do that. But I do need you to solve quadratics on this next test. And that's how you do it. You set them equal to 0, and usually this part factors. This one didn't actually factor. So you'd have to use the quadratic formula. It'd take too long. All right, cool. Now, the last... No, actually, I need to take a second to talk about yesterday. You had problems like this where you needed to make the base the same. Do you still remember how to do that? Make the bases the same and solve the same. There's a whole category question from yesterday that we haven't talked about yet. Should just clear that up first. Remember this deal where you make this into 2 to the 4th? And then the bases are the same, so then this equals this? We good on that? Okay. Here's the hardest kind. 8 to the x equals 16. Because you can't make the base 8 and you can't make the base 16. So what are you going to do? Make the base what? Say it. 2. Good. Make the base 2. Max, this 16 here, that's 2 to the what? Good. This 8 here, that's 2 to the what? Good. Now what am I missing? The x. Does that mean 30 something? No, that means 3 times x. All right, so then the bases are the same. Cool. 3x equals 4. X equals 4/3. All right. I think you all got that one, but I'm warning you on this next one that there is such a huge probability you will make a little algebra mistake. Just be really careful. It's the same kind of deal. It won't take you long to realize, I guess I better use 2 for a base. But, careful, careful. This next test could be called the careful test. That 4 right there, that's 2 squared. That 8 right there, that's 2 to the third. But what you do next is going to determine whether you screw this up or not. You bring this 2 down, and of course you know that's not 32. And you bring this x plus 1 down here, and that's where I think some of you are going to screw up. Finish your answer. Compare with the kid next to you. Don't be surprised if they get it wrong. Because either you know the little trick I'm talking about, or you aren't noticing it, and you're the one making the mistake. Okay. Compare with the kid next to you and see if you caught it.
Yeah, that's what I got talking.
All right. So that's supposed to equal that, right? So here's the mistake people make. 2x plus 1 equals 6. That's wrong. Do you see what's wrong? Raise your hand if you know what's wrong. All right. Good. Most of you seem to know what's wrong with that. It's because this is technically in a parentheses, and that means it's got to be distributed, and that means this is a 2. And that will get you a completely different answer, of course. So common for people to not know that. They're careful. Right there. Then let's finish it off. 2x equals, subtracting 2 would be 4. X equals 2. How many of you knew and caught that this was a 2 without my help? All right. If not, watch out. All right. And then if we're not even going to do this problem, I'm just going to ask you about it. Just look at it. How would you start? Would you square both sides? Good. Would you have absolute values that come in? No, you would not, because you squared both sides. That doesn't cause absolute values. It's if you square root. Would there be anything to do at the end? Let's say I get the answer of x equals negative 2 at the end. What do you do at the end? Do you remember? Check it. Would you just check negative 2? See if it actually works. Stick in negative 2. See if it works. No, because it causes you to have the square root of negative 1 on one side and the square root of 1 on the other side. And one side ends up being possible, but the other side, you can't have a square root of negative 1. It doesn't exist. It's an imaginary number. So you need to check your answers on that kind. There's going to be at least one like that on your homework, and there's going to be at least one like that on your test where you got to watch out. So what do you watch out for? The people with the backpacks. Or in this case, the square roots. If you have a square root in the problem in the first place, double check it. All right, now open up your homework, and you got a bunch of time to work. Way more than last hour, actually. I was able to cut out a few things. I was making them learn more stuff that they didn't need to learn today. All right, so you got your worksheet? You're going to skip 6, 7, 8, 9, and 10. Just cross off problems at 6, 7, 8, 9, and 10. And now let's do number 1 together. Would you read that one to me? 4 to the power of? Okay. Do you remember how to start these things? Miss Carr, what is that 2 down there? That's the square root. So we're supposed to do the square root of 4, which is 2. And why isn't the answer just 2? Because it's 2 to the 5th. See, you start with the root, and then you finish with the regular power. And what is 2 to the 5th? Well, if you didn't know, you can use a calculator. And I'm fine with that on today's homework too. 2 to the 5th, 32. Cool, there's the first one. Now let's do 1, 2, skip a few. Get to where the hard ones are. Would you read me number 11? I'm ready.
The third square of x plus 8.
Do you mean like that?
No.
How about this? X plus 8 and then, oh, okay. Now, just to clarify, it does have one of these deals, but I don't want that. I personally like it when it's got to the power of 1/3. It means the exact same thing. I'm going to do it this way. And what's it equal to, Jack?
You got minus 1 on the same side, and then it equals 4.
Oh, minus 1 first. And then it equals 4. Okay. So, step 1. You got to add 1 to both sides. X plus 8 to the 1/3 equals 5. Next, how do I get that 1/3 power off of there? Also known as the cube root. What's the opposite of that? It's cubing it. Putting it to the 3rd. See, that fixes 1/3. 1/3 times 3 makes it into a power of 1. Now, is this the kind where I do the absolute value? No, it's the fraction. I did not just do a fraction root on both sides. I just did a power of 3. It's only the fraction root kind where you do the absolute value. So then it's just x plus 8. 5 to the 3rd is 125. That'll be really easy now. It's all about when to check things like what kind do you have to double check the answer on? The kinds that have a square root in the first place. What kind do you bring in the absolute values? If you square rooted both sides. All right. Now you got a bunch of time. You got a kid next to you doing the same problems. You can ask them first. I'm also available, and that's all I have for today.